All right, so this is our notes, our vocab for Unit 2. We did just fill in our table of contents for this unit that we are starting. And so that looks like this. If you need to write that down while watching the podcast, please pause it now and do so, and then start it back up when you're ready. Now, we are going to look at this vocab page today. Another day, we will look at the second page that you got. So for now, just hang on to it, and I'll tell you where to put it in just a second, so keep up with it. All right. So on Thursday of last week, you watched a podcast over independent and dependent variables and took notes on it, which we just glued in on page 26, I believe, right? Okay. 26. Do you remember which variable we said independent represents? Like which letter, X or Y, is independent? The X coordinate. So that's the second blank here. The X coordinate represents the independent variable. Okay. Now, if you think about a situation or like a table or graph or something like that, there's an input value and there's an output value. Which one of those would be independent, the input or the output? Input. So that's what the first blank is. Okay, one way you can remember it is it starts input, independent. They start with the same two letters. All right. Or as you put something into an equation, it changes to give you the output, which is the Y coordinate. And output is the first blank. Okay, so let's look at what this looks like in a situation. Okay, so if I give you this ordered pair, which one of those numbers is my input? The 4, because it's in the X place, right? Which means, is it independent or dependent? Independent. Independent. All right, if I use the same one here, which one of those numbers is my dependent variable? 7. The 7, because it's my output or Y coordinate. Okay? All right, now what I want you to do over here to the side, notice I'm in both of those boxes there, I'm drawing 2 perpendicular lines. What does perpendicular mean?
It doesn't make a right angle.
It makes a right angle when they cross. Now, obviously, we're not perfect. We can't draw perfectly straight lines and perpendicular lines, but you can tell that's what it's supposed to look like. Okay. Which one of those lines is representative of the y-axis?
The up and down.
The vertical one. So this is my y here. So this horizontal one is the x. All right. So what's another word we could use for the y-axis? The y-axis. Output or dependent. I'm just abbreviating dependent. What's another word for the x-axis?
Independent. Input.
Input or independent. Okay, now let's say I give you a table. Generally speaking, X is on the left side, not always, but most of the time X is on the left side, or your input is on the left side. Okay, so this would represent our input, and Y represents our output. Okay, independent and dependent, input and output, those are words that are very common in science. Have y'all used those words in science before that you remember? Yes? Okay.
Yes.
All right. If not, you probably will at some point this year. Normally, it's, I think we normally talk about it in algebra before 8th grade science, but sometimes they change things up. All right. Our next 2 vocabulary words we're going to talk about at the same time, kind of like we did independent and dependent. Okay. So a relation is any set of ordered pairs. Now, what is an ordered pair?
Like X, Y.
Good. What's another word for that right there?
Coordinates.
A coordinate point. Good. Jay's on top of it today. So ordered pair means the same thing as coordinate point. That's an example right there. All right. So an example of what that might look like is this right here. Bless you. So is that a set of ordered pairs right there?
Yes.
So is it a relation?
Yes.
Okay, could I have 2 ordered pairs as a relation? Would it be a set if I gave you 2? Could I have 25 ordered pairs and it be a relation? Yeah, so it's just any set of ordered pairs. It doesn't matter how many there are. Okay? All right, now a function is a relationship. Now, what word do you see inside that word?
Relation.
Relation. So I'm underlining relation. Okay? Between 2 numbers where there is 1 input for each output. Okay, what did we say input meant?
Like what goes in.
Is it X or Y?
X.
Sorry,
X.
it's X, and output is
Y.
Y. Okay, so what it's saying is that we have 1 X value for each Y value. Okay? Now, here's an example of a function. Oops. All right. Does everybody have that written down? Let me ask you this. Would that right there that I just gave you be a relation?
Yes.
Why is it a relation?
Because there's an input for every output.
I'm talking about relation.
Ordered.
It's a set of ordered pairs. So is that a relation?
Yes.
Yes. What's the difference in that example that I just gave you and the example above?
There's an even number of inputs and outputs.
Okay, there's an what do you mean there's even number? Are you saying because like this one has 5 ordered pairs and this one has 4?
Yeah.
Okay, so that's something good to notice, but that doesn't really make a difference for this problem, like function, I mean. What else do you notice? How similar are those two? Except for the last one. Okay, now I want you to look at the last one right here compared to the other points in that relation. And what do you notice?
The -6 doesn't go with all the other points.
What do you mean?
Like the 4 and the 5 and the 20, it can, and the 2 can like all be divided by each other, but
Okay.
and the 7, 3, and the 21 can, but the -6 can't go all the way.
Okay, that's a coincidence. But I like that you're seeing that pattern. Okay, what's the X value there, guys?
The X is on the last one. It's 5.
Okay, do you see that X value somewhere else?
Yes.
Where else do you see it?
5, 3.
Okay.
So it's not the same.
All right, so do you see how there are the same inputs with different outputs?
So that would have to be 5, -6 also.
So if I don't write this one down, just look up here. if I threw in this point right here, would that still be a function?
Yes.
Yes.
Why?
Because there's input for every output right there, even though it's the same.
So do you see how I have the same input here, but the outputs match?
Yes.
That means it's a function. Now, if it looks like this right here, oops, I put it in the wrong spot. If it looks like this right here, what do you notice about those inputs?
They're the
They
same.
have different outputs, which means this is not a function. Do you see what I'm saying?
Yes.
Okay, so let me say this, all right? Think about a vending machine, okay? Let's say you go to the vending machine and you see that A1 has Cheetos. You're like, I'm going to get Miss Raymer some Cheetos, right? Okay, if you type in A1, should it give you a Snickers? No, A1 should always give you Cheetos, right? Okay, so that input, it doesn't matter how many times you stand there and put in A1, as long as it has that to give you, you see what I'm saying? It's always going to give you Cheetos, all right? So, if I look at this right here, let's say here's some inputs and here's outputs. Let's say I input 2 and my output is 7. You don't have to write this down. Okay, and my input is 2. Can my output be 4? No. So this situation right here, that's kind of hard to see, isn't it?
Yeah. Yes. That's why you had 272.
That's even worse.
Yes.
It's fine.
Okay. This situation right here would not be a function because this input has 2 different outputs.
Oh, I see.
Does that make sense now? Okay. So my definition, because I know this doesn't make a whole lot of sense all the time, I want you to write this down. No repeating x values with different y values. So in order for it to be a function, if the x values repeat, they better have the same y value. Okay? If the x values do not repeat, that means it's a function already. Does that make sense? Okay. Now, this is kind of like, you have to think about what the definitions are. Okay? Are functions relations?
No.
Okay, so function was this one right here.
Wait.
This is a function. Is that a relation? Yes. So every function is a relation, but is every relation a function? No. Okay, so think about it like squares and rectangles. Okay, this would be a rectangle. This would be a square. Are all squares rectangles?
Yes.
Yes, they're just more specific types, right? So all squares are rectangles, but are all rectangles squares? No. Same thing with relations and functions. All functions are relations, but not every relation is a function. Okay? Does that make sense? All right, what I want you to do now is fold those two together, the 2 vocabulary pages, and just put them in your journal on 23 and 24, but we're not going to glue them until we have that second one filled out. Okay, once you have that done, please go to 27 and 28, which is where we said we were doing function notes. And we're going to get started right there. All right, so now we're going to look at like where we're determining whether something is or is not a function. Okay, so what I want you to do on your paper is write number 1. Just like you see it. Is that a relation?
Yes.
Yes, because it is a set of ordered pairs, right? Okay, so what this is asking is, would that relation be a function? And then we have to determine why. We have to say why we know. Okay, so what is it that we're looking at to determine if it's a function or not?
The x value.
The x values. So my x values are,
1, 3, 5, 4, 9.
okay, what do you notice about those x values?
None of them are the same.
None of them are the same. So is this a function?
Yes.
Yes, it's a function, so I want you to write function. And it says, how do you know? So how do we know that's a function?
Because all of the x values are different.
Okay, so I'm going to write because no repeating inputs. And what did we say input means? The x. Okay, I want us to use input and output, or independent and dependent, because we know those mean x and y, but a lot of times on the test, they like to give you those words, input, output, independent, dependent, domain, and range are some more words we'll learn this week. And they like to use those instead of just x and y, because x and y everybody knows, and so that using that vocabulary is just one more way to try to stump you. Okay, so I want you to know that vocab. All right, so we know that one is a function because there are no repeating input values. All right, write this one down. So same thing here, we're trying to determine if this relation is a function. So what is it that we're going to be looking at? The inputs, or the x's, and what are my input values?
2, 1, 5, 1.
All right, so what do you notice on this one? There are 2 ones, okay? 2 of the same inputs. So when I see 2 of the same inputs, what do I need to be looking at? Their outputs that go with it, right? Or their y values. So what do you notice about those numbers? They're different. So is this a function? No, this is a non-function. And how do we know it's a non-function?
Because there's repeating inputs without the same output.
Okay, so I'm going to say because input 1, like I'm listing the number that repeats, input 1 repeats with different outputs. Does everybody understand that one?
Yes.
Okay, try this one on your own. Have you answered it? Go ahead and answer it. Bless you. All right, what do you notice about this problem?
It's got a pattern.
So the input values increase by 1 each time, 1, 2, 3, 4, 5. What else do you notice?
That they all have the same output.
They all have the exact same output. Does that make a difference when I'm determining if it's a function or not? No, it doesn't.
Well,
Does it matter that these 2 numbers right here are the same? No, it does not. Okay? It doesn't matter that the output repeats or that the output is the same as the input. What is it that we're looking for?
Function.
We're trying to determine if it's a function by looking at what? The inputs. So 1, 2, 3, 4, 5. Do any of my inputs repeat?
No.
So I have how many outputs for each input?
Equal.
I have one output for every input, right? So is this a function?
Yes.
Yes, it's a function because,
No repeating inputs.
good, no repeating inputs.
No X's.
All right, questions on 1, 2, or 3? All right, I'm not going to make you write every single one of these down, but let's talk through them. There is one I will have you write down, but we'll talk about that when we get to it. All right, so if we look at this set, it says which of the following is or are a function or functions. Okay, so we're looking at each of those individually and determining if each one is a function or not. All right, so if we look at the first one, what do you notice on the first one? There are two input values that are 2's. So when we see that they have the same input, what are we supposed to look at? The output, and what do you notice about their output? They are different, which means not a function. Okay, so that one's not a function. If we look at the next one, what do you notice?
All of them have the same X.
They have the same input, and what do you notice about the outputs that go with them?
They're
all different.
Now, let me ask you this. Okay, what if this one was a 2 and this one was a 4?
It wouldn't be a function
Why would it not be a function?
because they're still different.
I still have 2 different outputs. Y'all see that?
But if they were all 2's or if they were all 4's, they would be a function.
If every single one of them was a 2, do I have more than one output for that input?
Nope.
So that would be a function. But as it is, they all have the same inputs with different outputs, so this is not a function. All right, what about number 3?
It's a function
Why is it a function?
because
They have
it
different
doesn't have
inputs.
repeating
They all have different inputs, so it is a function. What about 4?
Yes. Different.
Different inputs, so it's a function. Does it matter that all of these outputs repeat?
No.
We could care less about the outputs, right?
Yes.
Unless there's repeating inputs. Okay? I want you to write down number 5 now.
You want to say answer?
If you want to. So what is it that I need to be looking at here?
The
Inputs.
The inputs. What are my inputs?
1, 2, 1, 4.
So what did you repeat? 1. So what am I supposed to look at now? The outputs. And what do you notice?
They're the
same.
They're the same. So is this a function?
Yes.
Yes, it is. So make sure you make note of that in your journal, that that is a function. Did you make note of that? Where? Did you write yes or no? Okay. Now, what's about to pop up on the screen, everything that you see needs to be written in your journal, words included, okay? You should have room at the bottom.
Can I show them a picture?
Quickly. Make sure you're using a pencil.
Are we still writing on 27?
Yeah, 27, page 27.
Sharpen mine up.
All right, so this problem says for the following to be a function, x cannot be which values? Okay, so if we think about this, could x be a 5? Yes, because then I wouldn't have any repeating inputs, right? Can x be 25?
Yes.
Could x be negative 42?
Yes.
So is it possible for me to sit here and do process of elimination?
Yes. Well,
I mean, could I ever list every single possible number and check it to see if it works or not? No. So what do I need to start with?
The other one.
The inputs that are there, right? Okay, so if my x were a 3, that point would look like that, right? Would that make it a function? No. So can x be 3? No. So we would list that as a value that x cannot be. List that because the question says x cannot be which value? So 3 cannot be x. All right? Now, if I try 4, which is the next one listed here, would that be a function or not a function?
Yes.
But the 4s repeat.
But that's the same
They would have the same output. So is 4 going to work?
Yes.
So do I need to list it right here next to my 3? No, because 4 is going to work. And then the next one is -2. Would that make it a function?
No.
No. So what do I need to do?
-2.
List it beside the 3. So that would be your answer for that problem.
And made the first one.
Okay. Any questions on how you do that? Okay. I'm going to give you your assignment now. It is front and back. There's not a whole lot to it. Let me show you what it looks like real quick. Skip part 1 because we didn't get that far. Okay, so skip part 1, start with part 2. Tell your third and fourth period friends that as well because I forgot to tell them to skip part 1. So you're going to start on part 2. It says which relations below are functions. So you're looking at all 3 and I need an answer beside all 3. And then with number 2, it starts asking why. So please make sure you explain why it does or doesn't work. Okay? On the back, starting at number 4 on the bottom, and then on the back, that's where you're talking about what x values that it cannot be.